Good morning, students. I believe you are ready for today's class. Your pen, your jotter, your writing materials are there alongside with you. And my name is Ilesomitope Joseph. I will be taking you through simultaneous linear equations. And this lesson is a continuation of our previous lessons. And in our previous lessons, we discussed about method of solution of simultaneous linear equations, which we talked about the method of elimination and the method of substitution. So in this lesson today, we'll be looking at the graphical method. We'll be looking at the graphical method per se. Okay, what is the lesson objectives? At the end of this lesson, you must be able to compile or you must be able to construct a table of values for the linear equation in two variables. Don't forget, it's in two variables. Then you must be able to represent a linear equation in two variables on a graph. Then you must be able to solve simultaneous linear equations graphically. Then the next part will not be captioned in this lesson. That will be for the other lesson because of our time. Okay, let's move on to what we have. The graph of an equation. When we have an equation, a straight line equation, and generally is of the form y equals mx plus c, where m is your gradient, x and y they are the variables, then c is the intercept. Now, before drawing a graph, you must make sure you make or you construct your table of values. Very, very important. And we call x and y the variables. X is the independent variable, y is the dependent variable, because y will depend on x. So to any value of x, there's a corresponding value of what? Of y. Now let's look at this example. We want to draw a graph of this equation y equals 3x minus 4. Since I'm not holding a graph here, and I know you do, please, you will be the one to do a lot of the work. You'll be the one to draw the graph and everything, and be sincere. Be sincere to yourself. Now, we want to draw the graph of the equation y equals 3x minus 4 for values of x from minus 3 to plus 3. And we have to read off the value of y when x is 2.5, and so on like that, and the coordinates of the point where the line cuts the axis. Now, someone will ask me what's the meaning of coordinates. Coordinate is just a way of writing an ordered pair of points. Let's say, for instance, x is 0 when y is what? 1. This is called a coordinate of points. Okay? Now, we are going to look at some calculations before making a table of values. You can do it on a rough sketch, and you can also show it on a space on your graph. Don't forget the equation that we are considering. Y equals 3x minus 4. Now, when x is minus 3, what is the value of your y? This will be minus 13. Yes or no? That will be 3 multiplied by minus 3. That will be minus 9. Minus 4. That will be minus 13. Now, when x is minus 2, that will give you minus 10. Yes or no? Because 3 multiplied by minus 2 will give us minus 6. Then minus 4. That will be minus 10. Then, when x equals minus 1, that will be minus 7. Then, when x equals 0, that will be minus 4. Then, when x equals 1, that will be minus 1. Yes or no? Yes. Okay, let's move on. When x equals 2, what is your y? That will be, you have y equals 3x minus 4. So that will be 6, 2, that will be 2. Then when x equals 3, that will be 5. Now, we're going to draw our table of values for the equation. Okay, don't forget what we are dealing with is just linear equation, and it's a single equation. You have -3, -2, -1, 0, 1, 2, 3. Okay, so what is your value? -13, -10, -7, -4, -1, 2, and 5. So this is the first thing first. This is the first step that you take. Now, how do we get these ordered pairs? How do we get these ordered pairs? When x is -3, your y is -13. That's why we have -3, -13. Then when x is -2, x is -10. That's why we have -2, -10. Then it follows like that. Now, the pairs can be plotted as points on a Cartesian plane. Someone will ask me, what is the meaning of a Cartesian plane? This is your Cartesian plane. That is any plane that has only two variables to be plotted. And your y is on the vertical axis and your s is on the horizontal axis. That is a simple example. Now, if you want to plot the graph of the equation, let's remind ourselves of the table of values. Don't let us forget that. The table of values, that is the first thing. We need to draw out our table of values, or we need to construct our table of values. Okay? I believe you are following what I'm doing, right? We have x and we have y. -3, -2, -1, 0, 1, 2, 3. Okay? So to any value, you have -13, we already have that, -10, -7, -4, -1, 2, and 5. Now, since you have your graph book there, just plot the graph accordingly. This is x, positive x, this is negative x, this is negative y, this is positive y. I will just tell you what to do. I will tell you what to do, then you'll be the one to do it. When x is -3, what is y? Y is -13. Here is your minus, here is your minus. So when you put your -3, you trace it out to go and meet where you have -13. And you put, either you put a positive sign like this, or you asterisk, or you put a circle to show the points. Now, you must have a straight line graph, because this equation is for a straight line graph. You must not have a curve at all. Okay, so when you plot all those values, you will have a straight line. And once you do that, you'll be able to find the value of y when x is 2.5. Now, when x is 2.5, you go to 2.5, that is in between 2 and 3. You're going to have 2.5. Don't forget your scale. Always use a scale of 2 centimeters to represent 1 unit. Are you getting me? So, if you are using a standard graph has 10 O's for 2 centimeters, while 5 O's is for 1 centimeter. Are you getting me now? Now, a particular O is for 1 unit. A particular O is for 1 unit. So that means after 2, the next O is for 2.1. The next O, 2.2. The next O, 2.3, 2.4, 2.5 will be at the middle between 2 and 3. And you trace what you have there. So after that, you have 2.5 in between 2 and 3. Then you now trace it up to go and touch the line, your straight line. Either yours is like this, or I don't know, anyhow. So you just go and touch the line, then you trace your answer to y-axis and you get the value of y. Now, you can do the same thing also on y. That is, when y is minus 2, that means we are going down here. When y is minus 2, you trace it to go and make this line, and you trace it up to x, whichever way, and you find out that your value of x is 0.7. Depending on the way your graph looks like. If your graph is looking like this, it will be different. If it's looking like this, but if you do it very well, your graph should be a straight line graph. And it's either it passes through the origin or it does not. It's not a must that it passes through the origin. Now, the line cuts the axis at, what is the meaning of that? What is the meaning of that? That is where the line, this straight line, where it cuts both the x-axis and the y-axis. What is that point? You pick out that point. You are having a graph like this, then it cuts, let's say it cuts here. So at this straight point, your y is, there's a value for y. You can read it, maybe it's 2 or 3. But on x, it will be 0. Now, on this value, there's a value for x, but on y, it will be 0. So that is the meaning of that. So when x is 0, y is minus 4. When x is 1.3, y is 0. So we have that. I think I've explained that when the straight line cuts cuts both the axes, both the x-axis and the y-axis, that is when you read. I think I'm going to draw a graph and I will screenshot it so that you can see this very well. I'm sorry for not making that available in this lesson. Okay, we notice that the 7 points lie in a straight line. That is after drawing the graph, after plotting all those points. So that's what we observe. And please make sure you make use of your ruler and your pencil to draw those lines. It must be a very perfect straight line. So now there are some things that we need to note here, that the variables in a linear equation are always separate and have a power of 1. Down is, I've explained that it must be a simple equation. It's not one that we have a power of 2. This is not quadratic. This is just a simple linear equation. Then the graph of a linear equation is always a straight line. If you are getting a curve, that means you are wrong. I've mentioned that before. So you must take note of that. It must always be a straight line. Then it is sufficient to plot only 2 points to be able to draw the line. So don't pick numerous points. And because we'll be using 2 equations, please, I will advise that we use -1 to +1 for any of our values that we want to use. That is value of x. This is for x. This is for x. So if 3 points lie in a straight line, the working is probably correct. Yes, because this will give us 3 points. -1, 0, then +1. These are 3 points on x. Okay. Now, I want to find, this one is still the same thing as the previous one. Okay, I will want you to do this on your own with the explanation that I've done. I'll pick the value of x for you. Don't worry. I'll pick the value of x for you. You'll be using, this is x and this is y. -1, 0, then 1. So to any value of x, which is -1, what is this? This is 1, this is 2, and this is 3. Are we correct? Yes. Okay. Now, so you just plot this on the graph and you follow what we have in example 1 or 2. Okay. Now, you have this graph. You have your positive y, your negative y, then your positive x, and your negative x. So just follow through, put all those points. Here you have -1, 0, you have 1 here, then here you have, let me see what we have there. The x is 3, that will be 1. Okay, that will be 3, 2, 1. So when x is minus 1, we have y to be 1. Okay, just trace it. I'll use pause. Sorry. When x is 2, when x is 0 rather, y is 2. This is this point. Put it here. Then when x is 1, y is 3. This is this point here. So you see that it will give you a straight line. This is equation y equals x plus 2. So you can now find the value of y when x is 3. How do you do that? X is 3. So don't forget this one still continues to 2, 3. Okay, just trace your 3 up on this. Then you trace it to the corresponding y. You can extend this number also for y. Okay, now you get your value. Then when y is 1, what is x? When y is 1, this is 1 here. You just trace it then to where it's so you get your value here. Okay, then write down the coordinate of the point where the line cuts the axis. Okay, that is where it cuts it here. So at this point your y will be 0 and you have a corresponding value of x. Then at this point, this is the point where it cuts the y-axis. So at this point, you will have a corresponding value of y, but your x will be 0. Now, the next example is to solve this graphically, the simultaneous linear equations graphically. This is the main work. This is where we are going to per se. But before we do that, let us rewrite this equation. You know, we have y equals this. So I will transfer y to this side, then this to this side. That will be 2x plus 1. Then this will be 2y equals x minus 4. Yes. Then you divide through by 2. That will be x over 2 minus 2. That is all you have. Now, I will advise that you use this table. Very simple. Use the table for x, this is y, minus 1, 0, 1. Then use the same thing for this. Please don't change your tables of value. It must be the same thing for both equations. So you must use the same thing. Minus 1, 0, 1. Now, let's start with the first equation. When y is minus 1, what is y? That will be minus 1. When it is 0, that will be 1. When it is 1, that will be 3. Then this, when it is minus 1, we have, that will be minus 1 over 2 minus 2. That will be minus 5 over 2. When it is 0, you have minus 2. Then when it is 1, we have minus 3 over 2. So these are fractions. So this is the same thing as, just write it in your note. This is the same thing as minus 2.5 and minus 1.5. Minus 2.5 and minus 1.5. Okay. And I told you that if you are using a standard graph, 2 centimeters represent 10 O's. So after 2, the next O should be 2.1. 2.2, 2.3, like that. So you can easily get it on your distance. So the second step is you choose a suitable scale. And I told you must use 2 centimeters to represent 1 unit. Okay. Then you must draw both lines. Extend the lines if necessary so that they intersect. You must extend the line. You must draw the equation of the two graphs on the same graph, not on separate graph, on the same graph. And you must extend those lines so that they both intersect. Then the next one is you must find the point of intersection. You must find out the point of intersection. Okay. Now, let me just use this as an example before we move to the next example. Let's say I'm using this as just an example. This is plus y. This is negative y, positive x, then negative x. This is just an example. Let's say, for instance, the graph that you drew is like this. Okay, this is for the first equation, for the second equation. Now, where do they intersect at this point? So, at the point of intersection, what is your y? At the point of intersection, what is your x? They both intersect at this. So, you just trace it on y-axis. Then you trace it on x-axis also. Are you seeing it? I'm not saying it must intersect at the middle. I'm just using this one as an example, just to explain. So, but when you draw your own graph, it must definitely intersect. So, at that point of intersection, you will trace it down to the x-axis, and you also trace it up to the y-axis. Either it's negative or it's positive, it does not matter. But just trace it up and down. Let me explain that again. Let's say this is a graph, and let's say this line cuts like this, and the other one cuts like this. You see where they intersect. So what is the value here? Then you trace it down. What is the corresponding value? Here is for y. Then here is for x. Do you see now? That's what I'm saying. Now look at this example again. Example 3. Now, firstly, if you want to write this, you must write it out in where you have y as the subject of the formula. So y equals 3 minus x. That is for equation 1. Then this one will be what? Y equals 3x minus 1. That will be for equation 2. That is, I've rewritten equation 1 and 2 to be like this by making y the subject of the formula, because it's very, very important. Then the next thing you do is your table of value. Your table of value. So your table of value, just use a very simple table of values. Use very simple one that will not be cumbersome for you. That will not be too. So this is x, this is y. Minus 1, 0, 1. Then this is x, this is y. Minus 1, 0, and 1. So now let's now go back to the equation. We have y equals 3 minus x for the first one. Y equals 3 minus x. Then y equals 3x minus 1. I think that is what we have. Okay. So you just start putting it. Since x is minus 1 here, put minus 1 here. That will be 4. This will be 4. This will be 3. And this will be 2. Then this, when x is minus 1, that will be minus 4. When it is 0, minus 1. Then when it is 1, that will be what? 2. So these are the values that you plot on your graph. Don't forget, you plot that on your graph. Then anywhere you have your intersection, you have y, you have negative y, positive x, negative x. So you draw all this on the graph. Then where they intersect is where you have the solution. So you write out the coordinates where they intersect, and that is what you have. So this is just one exercise. Please just do question 1 for me, because I have so many undone questions like the examples that you need to draw. So because of that, just attempt the first question alone, and maybe in your later time you can also attempt the other. So thank you very much. Take care of yourself. Bye.